Okay, last night's homework, so you were differentiating. I know I didn't give a chance to give you a homework because sorry about yesterday evening. I forgot I had myself booked into a first aid course for 3 hours and it was starting at 3:30. So I'm really sorry, but it was really good that I had forgotten because I didn't have to dread that I had to stay for 3 hours after school, and your man was really funny anyway, so it worked out well for everyone. So sorry about the no after school class. Right, okay, so we were differentiating exponential functions on page 293. That was the last thing we did, and we were looking at 1 to 7 on page 295, and I said if you'd have done them right, keep going. Right, does anyone need me to do anything 1 to 7? Yes, Nicola? 2 part 3, right, okay, so 2 part 3 is y equals x times, and the clue is in the way I say it, x times e to the power of 2x. What do you need to use? X times, it's x multiplied by e to the power of 2x. What do you need to use? Product rule. So you need to say u is equal to x and v is equal to e to the power of 2x. Right, okay. Differentiate here, you get du dx is 1. Differentiate here, you get dv dx is e to the power of the exact same thing. So equal to e to the power of 2x, and then you differentiate the power. So you differentiate 2x and you multiply it by 2. Is that right? And then, is it okay if I don't write down the formula, just fill it in? Right, so it's u times, which is x, times dv dx, which would be 2 times e to the power of 2x. I just put the 2 in front. Okay, plus v times, which is e to the power of 2x, multiplied by du dx, which is 1. Okay, and that'll do. Right, okay, that'll do. Yeah, there's not any multiplying out there that's going to make it any simpler. Is that alright? Okay, happy with that? Okay, so you had to recognise that was the product rule. Right, anything else there from 1 to 7, please? 3 part 3. Right, so 3 part 3 is the quotient rule. Right, okay, so 3 part 3 is y is equal to e to the power of 2x plus 1, so the 2x plus 1 is in the power all over e to the power of x. Now, actually, you could make life easier for yourself here because we can actually divide this, right? How do you divide powers? It's the top take away the bottom, isn't it? So that would be the same as e to the power of 2x plus 1, plus 1 take away x, wouldn't it? Top power take away the bottom power, so that would be the same as e to the power of x plus 1. Okay, so when you do the quotient rule, you can probably turn it, so then differentiate that, you get dy dx equals e to the power of x plus 1, and then differentiate the power, so differentiate x, you get 1. Okay, so if you do it using, did you do it using the quotient rule? Did you get it as far as there? Were you able to simplify it to that? No. Will I do the quotient rule just to show you it's the same thing? Right, okay, so u is above the line, so u is equal to e to the power of 2x plus 1. Right, okay, and v is equal to e to the power of x. Differentiate du dx is equal to e to the power of the exact same thing, and then you differentiate the power. So differentiate 2x plus 1, you just get 2, right? And then dv dx is just e to the power of x. You don't need to differentiate the power because when you differentiate x, you get 1, so it's the same thing, right? Okay, then the quotient rule, I won't write it down if that's okay. It's it's v multiplied by du dx, which is 2e to the power of 2x plus 1, minus, where am I, e to the power of 2x plus 1 multiplied by dv dx, which is e to the power of x, and that's divided by e to the power of x, all to be squared. Right, I told you not to bother simplifying that, okay, but I just want to prove that this is the right answer up here. Okay, so I'm going to simplify it, but if I was in an exam situation, that's my answer. Full marks, done. Right, okay, unless they actually say the word simplify. Okay, but here I'm multiplying here. What can I do to multiply? I can, what do I do with the powers? Add them. So if you add e to the power of x to the power e to the power, you get e to the power of 3x plus 1. Agreed? Okay, right, minus over here, again you're multiplying, so you add the powers, so you get e to the power of 3x plus 1. Agreed? Okay, all over e to the power of, raising a power to a power, you multiply, so x by 2 is 2x, isn't it? Okay, so up top, these are the same things, aren't they? So it's 2e, take away 1e. Right, they have the same powers. So there's 2 of them, take away 1 of them. So what you get? E to the power of 1 of them, don't you? 3x plus 1. That's like 2x take away 1x, which is 1x, yeah? Okay, does everyone see that? Now what do I do? To do division, what you do? Subtract. So 3x plus 1 take away 2x is e to the power of x plus 1, which is what I got over there a minute ago. Is that right? Okay, but going back, this line here will get you full marks. Okay, it's just if you spotted that earlier on, it makes it shorter. Okay, but you would never have to multiply out unless they say multiply out. Sometimes they do, because there's a lot of algebra in there, there's a lot of indices in there, so they're checking your differentiation and checking your what do they call, indices as well. Yes.
Why did the indices on the top that you added them, but then on the bottom you multiplied them?
Because that's the formula, as in I multiplied x by 2. So when you're raising a power to a power, you multiply. And when you're multiplying one term by another, you add the indices. Okay, but if you only have one indice and you're raising it to a power, you multiply. Do you see here I have 2 indices and I'm multiplying, that means you add them. So when you have 2 separate terms, multiplying, you add. But we've only one term, raising it to a power. That's rule number 3 in indices, which means multiply the indices. Is that right? Okay, so they're just 2 different rules from indices. Right, are we okay? Right, there's a lot of maths in that. Right, okay. Right, where am I going now? Or am I done? Or? Now I sound like a seed. Yeah. What am I doing next? 4 part 2. Right, 4 part 2, right, okay, I definitely have to use the quotient rule, because I cannot do any division before I start, right, because they're not the same terms, right, okay, so U is what's above the line. Am I doing the right one? V is what's below the line, X, then differentiate du dx. And what I get when you differentiate e to the power of 2x, what I get? Come on, participate, you do a bit of work for a change. E to the power of 2x multiplied by 2. Differentiate x, what I get? 1. So dv dx is 1. So then, if you don't mind, I'll just do it. It's v times du dx, which is 2 times e to the power of 2x, I just put the 2 at the front, Do I have to? God no. Right, minus u times e to the power of 2x multiplied by dv dx, which is 1 all over v to b squared, which is x to b squared. Okay? And you can leave it like that. Right? Okay? Because even if you multiply it out, you can't simplify it. So, right? Okay? That's the answer. You all happy with that? Right? Okay. Anything else? Were you okay with 6 and 7? Yeah? Do 6, yeah. Right, do 6. Right, y is equal to e to the power of 2x. Find d2y dx2. Okay, so let's go dy dx is equal to e to the power of 2x multiplied by 2, agreed? Right, which would, I could just put the 2 in front, 2 times e to the power of 2x. And then here, differentiate again, d2y dx2 is, the 2 in front doesn't matter, so just write down the 2 in front. So you're differentiating e to the power of 2x again. So e to the power of 2x multiplied by 2. Yeah, so you could simplify that to 4e to the power of 2x. Is that okay? Right, then the next bit, it says show that d2y dx2 minus 3 times dy dx plus 2y equals 0. Okay, so look, here we have an expression for y, here we have dy dx, here we have d2y dx. So you're just filling in your answers. So here we do d2y dx2, which is 4e to the power of 2x. Then I have a minus 3 times dy dx. dy dx, I have it here. It's 2e to the power of 2x. And then I'm adding 2 times y, and look at y is here, e to the power of 2x. Okay, so that, and I'm trying to show that when I work all that out, I get 0. So you get 4e to the power of 2x minus 6e to the power of 2x plus 2e to the power of 2x. And when you put all those, they're all the same. They're all e to the power of 2x. So that means you can put them all together. So 4, take away 6 would be minus 2, wouldn't it? Minus 2 plus 2 will give me 0. Right, so I can put all those terms together because they're like x's or y's or z's or whatever. Is that right? So you do end up getting 0 equals 0. Is that right? Happy with that? Okay. And 7, was 7 okay? Yeah? Right, okay. I want to move on to logs today. Okay, so just I just flash up the rule there on the computer, and it's the yellow box. There's no notes to write down here because it's nothing different. It's the yellow box that's in the book, and I just cut and pasted into my thing, just so you wouldn't have to look down. You can look at me, because I like when it's all about me. Yeah. All about me. Some would say egotistical, I wouldn't. I'd say PG. Right, okay, so here we go. Right, okay, so when you're differentiating a log function, okay, basically we can only differentiate log to the base e, right, okay, so we can only differentiate it when it's log to the base e. if it's log to any other base, we can't differentiate it. So that means we to use the change of base rule. We'll be revising the log rules as we go through this. Okay? So if it's not log to the base e, we cannot differentiate it. So we can only differentiate ln whatever. Remember, ln is log to the base e, right? Okay? So if you are differentiating ln x, right, when you differentiate it, it's 1 over x. So you just put 1 over whatever it's the log of. Okay? But that's fine if it's just x by itself, right? But if it's a bit more complicated, as in if it was 1 over x squared, if it was ln x squared you were differentiating, you put your answer is 1 over x squared multiplied by, what do you think you do? Differentiate what then? X squared, right? So if it's log of x, it's 1 over x. So if it's log of anything else, it's 1 over the anything else, and then you multiply it by differentiate the anything else, okay? So you can be writing, no, stupid, right, okay, no, wait, no. It always goes back to that page, I don't know why. Right, if you just write down example 1, right, okay, and then I'll write down the rest of them in a minute, okay, as we're going through them, right? So, example 1, and that's all ln, right? So, example 1, ln 1 plus 4x squared. Is that what it is? 1, yeah, okay. Right, so y equals, right, just example 1 written down. Right, I'll put the rest of it. Can I go? No. Have I gone? No, I haven't. Right, can I go? Right, okay. Example 1. Right, that line's on that for some reason. Right, so differentiate it. So it's ln 1 all over x squared. So you get 1 over whatever the ln is. So 1 over, what's the 1 over what? 1 plus 4x squared. Right, okay. And then, now you differentiate this bit. Just this bit. Right, okay. So differentiating the bracket, what do you get? 8x, yeah, okay. And if you want to simplify that to 8x on top and 1 plus 4x squared on the bottom, you can, but if you left it the other way, you'll be fine too, because you can't do any more simplifying with that. Is that right? Okay. Okay. Right, example 2. Y equals ln sine squared x. Okay, right, so ln sine squared x. Are we okay with that? Okay, so can I just, what I might write that as ln sine of x all to be squared, right? Just so, why am I writing it like that? Just so I remember it's the chain rule, right? Okay, is that right? So the first thing you do is you differentiate the log. So differentiate the log bit, what will I get? 1 over sine squared x. So that's the log bit differentiated. Now I have to differentiate sine squared x. So that's the chain rule. So that means bring the power down in front, leave inside the bracket exactly the same, reduce the power on the bracket by 1, which is to the power of 1, And then now I differentiate sine x. And when you differentiate sine x, I can never remember which one is the minus. It's just cos x, there's no minus. Okay, is that right? So you can simplify that a bit, right? Okay.
Excuse me, please, can our first year soccer players go to room 9 at break time for a brief meeting? Again, that's all first year soccer players to room 9 at break time. Thank you.
You know sine squared x, what does that mean? It's 2 sine x's down there, doesn't it? So sine squared x means sine x, yeah? So what can I do with one of the sine x's? Cancel. So I could cancel one of the sine x's on the bottom with one of the sine x's on the top, couldn't I? Right, just if you were asked to simplify it, so I'm left with 2 cos x on top, and I'm left with a sine x on the bottom. And that's my answer. Is that alright? Agree with that? Sorry. Is this down? Can I go? Right. Okay. Right. Example 3 is ln. So y equals ln the square root of 1 plus x to be squared. Right. What I do with that first? Right. What I do with that first? Instead of writing the square root sign, what do I write it as? Yeah, 1 plus x squared all to the power of a half. Okay, is that alright? Okay, so then differentiate dy dx. So differentiate the log bit first. That means you just put 1 over whatever you're getting the log of. So what did I put 1 over? Square root of 1 plus x to be squared. Or I could change that to a half. Right, I might in a minute. Right, now I have to differentiate this. So I need this. This is handy, isn't it? To differentiate this. Okay, so multiplied by, so differentiate the bracket first. Bring the power down in front. Leave the bracket exactly as it is. And reduce the power in the bracket by 1. So it goes to minus a half. Okay, is that right? And now you differentiate inside the bracket. So now you differentiate 1 plus x squared. When you differentiate 1 plus x squared, what will happen? 2x. Right, okay. So we might try and simplify this just for the hell of it. Right, well look, a half multiplied by 2. What would be a half multiplied by 2 be? Be 1, wouldn't it? So I can, is that okay with everyone? Right, okay. So I already have a 1 all over the square root of 1 plus x squared here. Right, I have over here, I could bring this downstairs, couldn't I? Because it's negative. So when you bring it downstairs, and will I turn it back into a square root? 1 plus x squared. Yeah. And there's an x left here at the end, isn't there? Right, are we all okay? Right. So when you multiply, right, multiply all the top. 1 by x is x on top. Multiplied by the bottom. Square root of 1 plus x squared multiplied by the square root of 1 plus x squared. What would that be? 1 plus x squared. And that's your answer. Okay? All simplified and everything. Right? Is that okay? I'm thinking example 4. Have I time? Oh, my watch isn't working. I need that. I have time. Right, okay. I was thinking example 4, we might use our rules of logs to differentiate. Okay, to make it easier. Right, okay. So it's ln the square root of x all over 1 plus x. Now, if I was to differentiate that, it'd be a nightmare, right, wouldn't it? Because I'd have to put 1 over the square root, okay, and then it'd look gammy, it'd be 1 over a fraction, right, okay, and then I'll have to differentiate this, and it's the quotient rule inside the chain rule. Listen, it's very complicated, right, okay, so the first thing I'm going to do is I'm going to use my rules of logs. So y is equal to x times, sorry, I forgot the log bit, ln x times 1 plus x what? All to the power of what? A half? Are you all with me? Right. Anyone spot a rule of log I can do there? It's going to make the differentiation way easier. I haven't differentiated anything yet. Right. Anyone know a rule of log? What can I do with that half? Please say someone remembers. You can bring it down in front, can't you? Right, the rules of log says you can bring that half down in front. So it's a half ln x time all over 1 plus x. Yeah? We all okay with that? Now, logs also tell me that if I have a fraction, what can I split? I can split up the logs. So I have a half into, how do I split? I can split up a fraction. So minus. So minus what? What will I write first? ln x minus ln 1 plus x. Okay, rules of logs. If you have a fraction, right, you can split it up and give them their own little log sign, right? Okay, now it's way easier to differentiate, right? So the half stays out here. Differentiate ln x, what you get? 1 over x. So, sorry, this is where I'm differentiating, so I should put dy dx here. Right? Here I haven't differentiated, I've just played around with, moved everything around. So a half times 1 over x minus what? How do I differentiate here? 1 over 1 plus x. And then I differentiate 1 plus x. But when I differentiate 1 plus x, what do I get? 1. So I don't need to put anything there. Okay? And that'll do. That's a lovely answer there, isn't it? Way easier to differentiate here. Right? Okay? Because if I were to differentiate up there, right, okay, I'd be putting it 1 over all of that. Right? Okay? And then I'd be using the chain rule to differentiate the bracket, and then I'd be using the quotient rule to differentiate inside the bracket, okay, and 3 pages later I'd get to this answer, right, okay? So sometimes it's easier to use the rules of logs, right, before you differentiate. Sometimes it's the same thing, right, okay? So I didn't use them in the previous ones because it was pretty much the same number of lines that it would take me to do them, okay? Will we try a few of these for homework, please? Okay, so we're on logs and we're doing page 298. Right, let's do 1 to 10. Right, okay. But can I point out, right, have 1 to 10 open there for me for a minute, right, okay, just looking at 1 to 10, right, 1 is grand, right, 2 is grand, 3 is grand, 4 is fine, 5 is fine, 6 is fine. What I do with 7, look at number 7, what have I to use? The product rule, yeah. What have I to use number 8? Product rule, don't I? Right, okay. What have I to use in number 9? Quotient rule. Right, okay. And in number 10, right, I'd say use a few rules of logs. Right, okay. It will make life easier, right, before you differentiate. Right, okay. Right. So in number the last one in number 10 you don't have to do because that was the example. Right, okay. So you don't have to do 10 part 6 because that was the example. Okay? Right. But, yeah, I'll leave it with you. Yeah. Okay.